we can extend this. We have the limit as theta approaches 0 of sine theta over theta equals what? Okay. It is also true that the limit of, how do I want to say it? I'm going to say f of x. So maybe we have some expression, like a 3x or a 7x. If that expression goes to 0, then the sine of f of x over f of x still goes to 1, as long as the limit as x approaches 0 of f of x equals 0. Here, I'm actually going to reset. I'm going to keep this as an x there. So what that means is, if we had a similar expression, if I were going to plug in a 0 for my x and I'm still getting 0 on the bottom, as long as the argument of sine and the denominator of this are the same, we can still say that entire thing approaches 1. So that is the big trick that we are going to be using on our limits today. So let's look at this. I want the limit as x approaches 0 of sine of 7x over 4x. Okay. Can we agree that if I put in a 0, 7x would approach 0? Right. If I put a 0 on the bottom is also 0. But I can't use that rule because the 4x and the 7x don't match. So we need to try to make them match. I cannot change the angle of my trig function, so I cannot touch that 7x. So what I really need is to get a 7 on the denominator. So we can do that if we multiply the top and the bottom of our fraction by 7. Okay. So this gives me 7 sine of 7x over, I'm going to write this as 4 times 7x. So instead of actually multiplying the 4 and the 7, I'm just going to leave them separate. Because then, right now, I could separate this into the 7/4 times this piece. As x goes to 0, what's 7/4 going to? Not a trick question. There's no x in it, so it's still 7/4 times the limit as x approaches 0 of sine 7x over 7x. This piece goes to 1. Because I can't plug in and give me 0 on the bottom, but since these match, I can use that rule and say it goes to 1. So the entire thing goes to 7/4. So our trick is going to be to multiply something else into the problem if needed, so that we can get the angle of the trig function to match the denominator. And then we can use that rule. Questions there? All right. If I look at this one, can't I just plug in my 0? No, because I get 0 on both the top and the bottom, so that doesn't work. Do I have a limit rule for tangent? No, only for my sine. So let's rewrite this. So tangent can be written as sine over cosine. and each of them would get that 3x. We can't leave a fraction in a fraction, but this is really equivalent to the limit as x approaches 0 of sine 3x over x cosine 3x. So I can just drop that cosine down to the bottom. I'm going to separate this a little bit. I have my sine 3x and I also have an x. I'm just going to pull this cosine out to the side for a while. Everyone still following? Okay. At this point, for the first one, what do I need in order for that to be able to simplify? Right, I need a sine 3x over 3x. So, okay, if I do this, tell me if I lose you. If I add the 3 on the bottom, we have to put it on the top as well. I don't really want it in this fraction. Can I just add it over here in this one? So I'm kind of skipping a step. I just really multiplied top and bottom by 3, but I just...
But we can choose where it goes.
Yeah, because it's all one term. It's not addition and subtraction. Since it's multiplied, you can put them in whichever fraction you need. So now we should be able to evaluate this. Because on the first one, the 3x's match, so that one's going to 1. Times 3 times 1 is 3 over cosine of 0 is cosine square root of 4 over 2, so that is 1. And we get 3 for our answer. Take a second, look at this one, see if you can figure out what to do. So we could rewrite this as sine theta over theta times sine theta over theta. Now there are a couple different ways of doing it. You could have put one big square on the outside, because we know we can bring a limit inside and then square the answer. Or I just recognize I have 2 sines and 2 theta, so I just split them up. As theta goes to 0, this goes to, and this goes to, so 1 times 1 is 1. So really the big rule we are using every time is that limit as theta approaches 0, sine theta over theta equals 1. Okay, if I look at this one, let's start pulling it apart. I have a sine 2z. What do I need underneath it out of these two things? The z. I don't need that cosine, so I'm just going to pull it over in a fraction by itself. Okay. So the first one, what does it need on the bottom? And if you're going to put a 2 on the bottom, you need a 2 on the top. I'm just going to put it in the second one. Then this expression goes to 1 times 2 times 1 is 2. Cosine of 0 is get 2 for our answer. We're going to do another one with you, and then you're going to do another one on your own. Do you guys, are you catching the pattern here, what we're trying to do each time? giving the sine, and then whatever your angle is needs to be the denominator. Look at this one. That square on the top means we have two of those. Theta squared is the same thing as saying theta times theta. So we are going to pull these apart. We're going to do sine 3 theta over a theta. I have another sine 3 theta over a theta. And I have a 1 over cosine theta. So I just write mine like this to make it a little more obvious what we are doing for each piece. For this one, what do you need on the bottom? 3. But if you put a 3 on the bottom, you need a 3 on top somewhere. Which of these fractions would you rather put it in? The second one, it's also a sine 3 theta over theta. So what do we need on the bottom? A 3, so that means we need another 3 on the last one. So sine 3 theta over 3 theta goes to 1 times 1. 1 times 3 is 9. Cosine of 0 is 1. And we get 9 for our final answer. Yes?
How's it cosine of 0?
You're plugging in theta is approaching 0. Any other questions? Okay. You guys try this one. So what's this one need? So if you add a 2 on the bottom, you also add 1 on the top. Then we know this goes to 1 times 2. And you should get 2 for your final answer. Alright, let's try some more challenging ones. Okay, if I'm looking at this one, we always check with our limits. Can I just plug in from the beginning? No, because I get 0 over 0. So that's the issue there. If you had a different angle here, we might be able to just plug in and evaluate. Now, our trick only works if it's a sine x over x. So I would really need the top to be sine 2x over 2x and the bottom to be sine 5x over 5x, right? Since neither one of these is currently divided by x, I need to introduce that into the problem. So the first thing I'm going to do, we know if we did the same thing to the top and bottom, it's legal. I'm going to multiply by 1 over x on top and bottom. Now looking at this, we've kind of made our problem uglier, but we're going to get to the answer from here. What else do I need in my problem? This one needs a 2, so if I'm going to put a 2 on the bottom, we also have to put the 2 up there. This one needs a 5. Okay. So, think of this, it's like 2 times that fraction and 5 times this one. If we evaluate, on the top, we have 2 times, the sine of 2x over 2x goes to 1. On the bottom, we have 5 times sine of 5x over 5x goes to 1. And we get 2/5. Any questions on that one? Probably one of the most challenging ones we've done so far. Just remember, whatever you do on the top, you have to do on the bottom. One last one. What are your thoughts? Where would you start? We have to change our cotangent to sines and cosines. So we get the limit as x approaches 0 of x times cotangent is cosine over sine. Okay, I'm going to reorder this. I'm going to make it an x over sine x times the cosine x. I put this one on here intentionally. This is very similar, but it's flipped. It's just the reciprocal of what we've been doing, right? And the one we've been evaluating, the limit goes to 1. The reciprocal of 1 is still 1. So this actually works if it's flipped as well. So you don't have to say anything extra, you can just say that goes to 1. Cosine of 0 is 1. Oops. And 1 times 1 is 1, not 2. Okay. Questions there? Alright, so you have quite a bit of time to work now. Hopefully you have finished at the very least the day 1. Well, did we turn in day 1? Yeah, so we have got that one done. Day 2 and 3 are due tomorrow, so you've got some time to work now and ask questions if you need help with this.